All right, this is the integral application worksheet. Any problems that have the little asterisk next to them are calculator allowed. Otherwise, we should practice without a calculator. We'll need to be able to do both for our AP exam. So problem 1 is no calculator. It says during the worst 4-hour period of a hurricane, the wind velocity in miles per hour is given by this for time 0 to 4. Find the average wind velocity during this period. So we're given a velocity function. They want us to find average velocity. So this is the average value formula. Velocity average is equal to, it's 1 over 4 minus 0 times the integral from 0 to 4 of v of t dt. So we should put v of t in parentheses to multiply it by dt. And then we're going to start integrating this. So 1/4. So this becomes 5t squared over 2 minus t to the third over 3 plus 100t. We're evaluating from 0 to 4. And let's see, do a bit of math here. So if I plug 4 in, I get 16 over 2, which is 8. So this is 5 times 8. Minus 4 to the third is 64 over 3 plus 4 times 100. And I always write this in. I know 0, all of these have a t in them, so I'm just going to get 0. I get into this habit because if there are trig terms over here or a value that is constant, then this will be something other than 0 possibly, so I want to consider it. So this is 40 minus 64 over 3 plus 400. Now, we have a 1/4 out in front. So to make my number smaller, I'm going to distribute the 1/4 through right now. So 40 divided by 4 is 10, minus 64 divided by 4 is 16 over 3. 400 divided by 4 is plus 100. Let's see, this is 110 minus 16 over 3. 110 becomes multiplied by 3, 330 over 3 minus 16 over 3. So 314 over 3. And my label on this, we're still getting an average velocity here, so it would still be miles per hour. How far do you have to simplify this for the AP exam? I think you can leave it unsimplified, but it's more likely that maybe this is a multiple choice problem and you do need to be able to do the math. So just because you might not have to simplify in free response doesn't mean that you can forget how to do this math. So it's worth practicing. All right, number 2 is a calculator problem. So I'm going to set it up first and then I'll hop over to Desmos. Suppose the current world population is 6 billion and the population t years from now is estimated to be p of t equals 6, that's because of the 6 billion, times e to the 0.024t. Based on this supposition, find the average population of the world in billions over the next 25 years. So again, they're giving us a population function. They want the average population. So this is p average. This is the average formula again, average of a function formula. So 1 over 25 minus 0 times the integral from 0 to 25 of p of t dt. So if this were on an AP test and it's part of a free response, we would need to write this out. You're getting credit probably for setting up the formula. And you can either type it in all together, or I like to do p of t in its own little line. I don't really know why I like to do that, but I just like having p of t here. And then once I've defined that, I can do 1/25th int for integral from 0 to 25. I can just type in p of t dt. And what I kind of like about this is a lot of times my students forget to write dt. So then they don't get credit for their integrand. But this will not give you an answer until you type dt. Or if you write it wrong, dx, that's wrong too. So this is I kind of like that once you spot check there. If it's calculator, you do not have to show what this integral actually comes out to. So that's why we're just typing this in. This is a value for population, and it's measured in billions. So I'm going to say a billion people. All right, our next one is no calculator. So let g of t equal this function. It's the number of gallons of water in a cistern t minutes after an outlet pipe is opened. So this is just a number of gallons. It's not a rate. Find the average rate of drainage during the first 5 minutes and the rate at which the water is running out at the end of the 5 minutes. So this is not a rate. So this is not G average. This is the average rate of change, the AROC of G of t. So that formula is G of 5 minus G of 0 over 5 minus 0. The second part, the rate at which the water is running out, the rate at which the water is running out is G prime. They want G prime of 5, so I'll find G prime of t for that part. So let's start with the AROC. So I'm going to calculate G of 5 off to the side. So if we plug 5 into this, we get 10 squared. So 400 times 100 is 40000. You just count your zeros here. So 40,000. G of 0 is 400 times 15 squared. 15 squared is, what is that, 225? Now, again, how much do you have to simplify this? I guess you don't have to simplify it, but again, it's good to have these math skills. If this is multiple choice, you might have to simplify it to find the right answer. So I'm going to do 225 times 4, and then I'll just multiply that answer by 100. So that's 20. I guess I could do this too. 200 times 4 is 800. 25 times 4 is 100. So this should be 900. I can go about things the old paper and pencil way as well. Yeah, that's 900. So then remember to multiply it by 100. So that's 9 with 4 zeros, otherwise known as 90,000. So now I have 40,000 minus 90,000 over 5. That's negative 50,000 over 5. That's negative 10,000. And what's the label on this? G is measured in gallons, and we divided by minutes. So gallons per minute. That's the average rate of change. What's the instantaneous rate of change at, it says at the end of 5 minutes, but that just means G prime of 5. We're still in that 5 minute mark there. We're not going to round it up to 6 or anything. So G prime of t, let's see. So power rule first. So that's 800 times 15 minus t to the first power. Remember to chain rule. The derivative of 15 minus t is negative 1. And then what's G prime of 5? So let's make this negative 800 times 15 minus 5 is 10. So that's negative 8,000, still measured in gallons per minute. Now we're switching back to calculator. So oil is leaking from a tanker at a rate of 1,000 e to the negative 0.3 t gallons per hour, where t is given in hours. Approximate the amount of oil that leaks out. So that's going to be a number of gallons in the next 8 hours using a midpoint Riemann sum with 4 equal subintervals. Okay, so let's figure out our delta x first, or our delta t, I should say. Delta t is 8 minus 0 over 4 equal subintervals, so 2 hours for each interval. And we're going from 0 to 8. So if you cut that into 4 equal parts, count these every 2 hours, those are our subintervals. And then remember, I'm not actually graphing this, but remember this says a midpoint Riemann sum. So really the height of your rectangle is here. So the midpoint is at 1, 3, 5, and 7. All right, so we are trying to do the integral from 0 to 8 of this 1,000 e to the negative 0.3t dt is approximately equal to, every rectangle would have a delta t of 2 times, let's define this. Let's go ahead and say r of t equals 1,000 e to the negative 0.3t. You can define that on your AP test, like let this be true. So then when I say r of 1, it will be correct what I'm setting up here. You do have to define that somewhere on your paper since it wasn't named in the problem. Okay, and I'm going to go over to my calculator to see what this comes out to. So in my calculator, I'm going to again say r of t equals 1,000 e to the negative 0.3t. I want to double check that I have the right equation. Yep. Okay, so this was 2 times r of 1 plus r of 3 plus r of 5 plus r of 7. Rounded to 3 places, I'm getting that this is 2,985.949. This is measured in total gallons. That's gallons leaked out. You don't have to say that, but I think it's a good reminder to yourself what you're trying to find here. So that's how many gallons we're approximating have leaked out without doing actual integration. Okay, number 5. In a marathon, when the winner, calculator allowed, by the way, when the winner crosses the finish line, many runners are still on the course, some quite far behind. If the density of runners X miles from the finish line is given by this, so R is the density, of this ugly equation, in runners per mile, how many runners are within 8 miles of the finish line? So we want to go from mile 0, which is the finish line, to mile 8. If we integrate from 0 to 8, r of x dx, we're taking runners per mile and we're multiplying it by miles. So that will leave us with runners. All right, so all I have to do is type this in carefully. I discovered when using Desmos, even though sometimes the problems are typed in with these square brackets, Desmos does not like that, so don't type in square brackets here. So r of x equals 20, use parentheses, 1 minus cosine of 1 plus 0.3x squared. Boom, boom. Yeah, if you, let me just show you. Oh, maybe. I have all kinds of brackets. Okay, so if I take this out and do that, it didn't, see how the graph went away? It didn't like this. And then when I try to do the integral from 0 to 8 of r of x dx, it's like, no. Now the reason is not super clear. Cannot index a number with a number. I'm sure that square brackets are some sort of, I think there's some sort of domain feature or something for Desmos. So just use parentheses and everything works out fine. So this is 162.857. Now we're talking about runners. This is not thousands of runners or anything. So let's go ahead and round that to the nearest runner, which is 163 runners. Part of the reason they ask you to include units in your answer is because they want to know if you know that it makes sense to round up to a whole runner and for things like that. Okay, number 6, non-calculator. The rest of these are non-calculator. All right, so find the average value of this function. Let's let that equal f of t over the interval -2 to 1 inclusive. So we want to find f average, and that's going to equal, so it's 1 over, this is the integral from -2 to 1. So 1 over 1 minus -2 is going to be 1/3 of, let's just make this t squared over 2 minus t cubed over 3. little less writing, dt. All right, so what did I say? I said that's 1/3. Let's integrate this. So this is t cubed over 3 times the 2 that's already down there. So t cubed over 6 minus t to the 4th over 3 times 4, 12. We have to go from -2 to 1. So again, how much do we have to simplify this? If it's free response, not much. But if it's multiple choice, they're going to have the worked out answer on here. So let's practice. So 1/6 minus 1/12 minus, put in -2, so -8 over 6. And then putting in t to the 4th will make this -2 positive, but there's still a subtraction in here. So 16 over 12. Now, each of these can be reduced, so let's do that. -4 over 6 is -8 over 6 is -4 over 3. And same with 16 over 12. Divide by 4, you get another -4 over 3. Okay, so this is 1/3 times 1/6 will be 2/12. 2 over 12 minus 1 over 12 is 1 over 12. Minus -8/3, so plus 8/3. Let's change 8 so that it's over 12. Multiply by 4 over 4. So now we get 1/3 times 33 over 12. And of course we can cancel here first. 11 over 12. Again, you are expected to do all of that without a calculator. Like, this is the kind of computational math that there's not a ton of, but it's not unheard of to have that on a non-calculator part. Air is escaping from a balloon at a rate of r of t equals 4 minus t to the 1/2 cubic feet per minute, where t is measured in minutes. How much air escapes during the first minute? So t is measured in minutes. So this is just the integral from 0 to 1 of 4 minus t to the 1/2 dt. So let's get that antiderivative. That would be 4t minus t to the 3/2, because you're adding 1. And then instead of divided by 3/2, let's have multiplied by 2/3 from 0 to 1. Put the 1 in first. So 4 minus 2/3 minus 0. Plugged into both of those. So what is this? 12 over 3 minus 2 over 3 is 10/3. And what's my label? This is how much air, and this is cubic feet per minute times minutes. So this is cubic feet. That's how much is leaked out. Number 8, a particle moves along a line so that its acceleration is given by this. If the particle is at the origin at 0, that's a position. Let's call position S. So S of 0 equals 0. And it's 3 units to the right of the origin when t equals 1. That's another position. S of 1 equals 3. Then find its velocity at 0. So we want v of 0. All right, so we're given acceleration. So we can integrate acceleration to get a v of t. This will be an indefinite integral because I don't have any information about velocity values yet. So just the integral of -t squared dt will be velocity. So v of t is equal to -t to the 3rd over 3 plus c. And again, I can't find c yet because I don't have any velocity values to plug in, and I don't want to use an average rate of change as a velocity because it's not instantaneous. But I have positions, so I can get to a position function by integrating what I have for a velocity. So let's integrate -t to the 3rd over 3 plus c dt. I'm going to bring this up here. So that makes s of t equal to -t to the 4th over 3 times 4, so over 12, plus c times t. And then there would be some other, I don't want to use plus c again, so let's just use another letter, plus d. There would be a constant of integration for this integral too. Now I have values I can plug in. So You don't want to start with 1, 3 because that would still give you two unknowns, but start with 0, 0. Position is 0 when I plug 0 in for t. So that's 0. So that means that d equals 0. And then that also means that, so okay, I know that. So then I can also say, well, position is 3 when I plug in 1. So negative 1/12 plus c is equal to, and the plus d is 0. So I can solve for c here. So 3 and 1/12, or what is that? 36 over 12 plus 1 over 12 is 37 over 12 for c. Okay, and then remember, we're going back to velocity here. So for velocity, it's the c value that I needed. So now let's go back to this and say, all right, the velocity equation, now I know it's negative t to the third over 3 plus c, which I just figured out was 37 over 12. And they want v of 0. Well, v of 0 is just 37 over 12. And there are no labels on this, so that's just going to be my answer. All right, number 9, this is no calculator. This picture, disclaimer, not drawn to scale. The sketch below shows the graphs of x squared minus 4x minus 5, it's parabola, and the line x equals k. Find k such that this area A and this area B are equal. Equal meaning one is, let's see, do I mean that the one's negative and one's positive? Yeah. Meaning like this area, this negative area is the same as this positive area. So let's just start there. We want like negative A to equal B, or A to equal negative B, whatever. What is the area of A? Well, I wasn't given bounds right here, but I can find them. We can begin by saying, well, what are these two numbers? Let's figure out, when is x squared minus 4x minus 5? When is that equal to 0? Because I would like to set this up. I don't want to have three unknowns. I don't want to have A, B, and K as the unknown. All right, so this factors into x minus 5, x plus 1. So x equals 5 and negative 1. So this is negative 1, this is 5. Okay, that helps. And then k, we don't know. It's 5 plus something. All right, so let's set this up. So A's area is negative, so but I want these to come out both positive here. So it's negative integral from negative 1 to 5 of x squared minus 4x minus 5 dx. That should equal the area of B, which goes from 5 to some value k, and it's still the same function, x squared minus 4x minus 5 dx. So a problem like this, you get credit for probably finding those integration bounds or maybe setting it up as well. All right, the nice thing about these is they're going to have the same antiderivative, so x to the third over 3 minus 4x squared over 2, so 2x squared, minus 5x. So this side goes from negative 1 to 5. This side is the same antiderivative, no negative out in front. And it goes from 5 to k. So let's just go ahead and start plugging stuff into this. So start with plugging in 5. 125 over 3 minus 2 times 25 minus 25. I'll figure out what that is later. Minus negative 1/3 minus 2 plus 5. That's this side. And it equals, I don't have a lot of room here, so it equals k to the third over 3 minus 2k squared minus 5k minus 125 over 3 minus 2 times 25 minus 25. Now, before you start doing a bunch of math, we're going to have on this side, we're going to have a minus this parentheses here, This will become plus. So say I've distributed that already. On this side, we have the same minus parentheses. So those two things cancel out. So now it's negative 1/3 minus 2 plus 5 plus 3 equals k to the third over 3 minus 2k squared minus 5k. All right, let's do this math here. This is 9 over 3, so this is 8/3 equals k to the third over 3 minus 2k squared minus 5k. Let's multiply this by 3. 8 equals k to the third minus 6k squared minus 15k. All right, I multiplied everything by 3. And let's see, get this equal to 0. All right, now this is a little tricky because you can't factor by grouping here. Because factor by grouping isn't going to work nicely. I wonder if I rearrange a couple of things, though. No, I think factor by grouping still doesn't work nicely. If I'm not allowed to use a calculator, there's this kind of obscure thing that says, like, well, there's this rational root theorem that says every polynomial we know has every odd polynomial has at least one rational root, or I should say real number root. And if a rational root exists, it'll be factors of the last term divided by the first term. So like plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. To streamline some things a little bit, there are two roots where k equals -1 and k equals 8 that actually work in here. You could check them with synthetic division to see like which one comes out to 0. Or I could type this into my calculator. But if I'm using a calculator, then maybe I would have crunched some of these numbers, a bit more nicely. But anyway, let's type this in. So say I am allowed to use a calculator and I take it all the way to this point. I would be looking for, I don't know if you can use K's. Let's see. No, let's just do this. Let's just do this. F of x equals, because I'm not sure and I don't want to take the time to figure out if I can do that with K's. So yeah, when is this equal to 0? So it looks like at -1 and 8. Okay, now are both of those possibilities -1 and 8? So -1 is one of the zeros. So like, okay, A and B would have the same area if K is just A. Well, that's not really what we're looking for because it says, I think it says in here, find the value of K so that they have equal areas. I think we're looking at K needing to be to the right of B. So let's say K equals 8 is our only option. Now, if I could have used a calculator that whole time, how would that have changed my process? So it's just that I could have had a numerical value for this a bit faster. So let's just take a look at that. The negative integral from -1 to 5 of x squared minus 4x minus 5 dx. So that gives you 36. And then it would just be still going through and doing this side of the equation and getting it down. So it just does some of the math for you where you have like 36 equals this minus 36. And then, okay, well, this equals, whatever, 0. And then you go through and solve for that. Either way, I think that you would still have a lot of the setup and the work to do. So anyway, I'm using a calculator to find my final answer. That's all I'm saying. There are commonly problems where they say make these two areas equal or find k to split an area in half or something like that. So the setup, this step right here, is the most important part.